Can an artificial machine really think? Does the mind just consist of neurons in the brain, or is there some intangible spark at its core? For many, these have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's.
What's 75 degrees Fahrenheit in Celsius?
75 degrees Fahrenheit.
Spell Fahrenheit.
Fahrenheit. F-A-H.
Self-driving cars. 8 years ago, Google brought the automobile industry into Silicon Valley, declaring a marriage between cars and big data. Today, the cars are being tested without a safety driver for the first time. We are entering an age where we will be enjoying commercial self-driving cars, which can hopefully cure the epidemic of road accidents that claim over 1 million lives every year.
Pythagoras,
The father of mathematics and music.
mathematics and music.
First, we'll need a string. Stretch it good and tight. Plunk it. Now divide in half. Plunk again. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. From these eggheads, the Pythagoreans, with their mathematical formula, came the basis of our music of today. It was our old friend Pythagoras who discovered that the pentagram was full of mathemagic. The two shorter lines combined exactly equal the third. And this line shows the magic proportions of the famous golden section. But this is only the beginning. Hidden within the pentagram is a secret for creating a golden rectangle, which the Greeks admired for its beautiful proportions and magic qualities. It can mathematically reproduce itself indefinitely. All these rectangles have exactly the same proportions. To the Greeks, the golden rectangle represented a mathematical law of beauty. We find it in their classical architecture. The Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. These same golden proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world.
John von Neumann. John von Neumann was a Hungarian-American mathematician. He was a pioneer of the application of operator theory to quantum mechanics, and a key figure in the development of game theory.
Game theory, and it's the branch of math that deals with picking outcomes when there are multiple factors at play, each with a different goal. Game theory wouldn't be of much use if all it did was help you win at risk. Fortunately, there are some much bigger scale games out there like economics, psychology, politics. You may not be placing a pawn on start and rolling a die, but you are trying to win something. Okay, so you run a shop where you sell tongue depressors. Guess you decided to go where the really big money is. But guy across the street has opened another tongue depressor shop. You have to outsell him. No, like, you really want to bury this guy. But how? Well, enter game theory. If we suppose both shops are selling their wares for equal prices, there are a few ways this game could go. And in this simplified example, maybe a little common sense, you've determined that if your competitor raises his prices and you lower yours, he'll be done and dusted before he knows what hit him. So as you can see, game theory, despite the name, is still math. It uses all kinds of numbers and equations and matrices to show the strategies that should be used to maximize our advantage and minimize our opponents.
Gottfried Wilhelm von Leibniz was born in Leipzig in what was then the Holy Roman Empire in 1646. What did Leibniz discover back in 1675, over a decade before the publication of Principia? Well, he used integral calculus for the first time in history to find the area under the graph of a function, which might not sound impressive, but it is. In doing so, he made up some important notation or symbols, including the d for differentials and the integral sign, which is a long S standing for the Latin word summa or highest. We still use Leibniz's notation today.
Luca Pacioli. Most of us don't know who he is, but all of us depend on what he's given us. He's the father of accounting as we know it. The unsung hero of the Renaissance.
Luca Pacioli was an important figure in the Renaissance, and his life and work underlines the essential interrelationship between art, business, and science of his time. Without this relationship, the Renaissance could not have taken place.
The success of the personal computer industry and Microsoft is based on the spreadsheet. And the spreadsheet is a direct evolution of the double entry system published by Luca Pacioli.
With the publication of his Summa, Pacioli's place as a major intellectual figure of the Renaissance was guaranteed. Its full title speaks of a book about mathematics, the collected knowledge of arithmetic, geometry, proportions, and proportionality. But just one small section within the book is what changed the future of business and economics. Through the Summa, Pacioli became the catalyst that launched the past into the future, lifting the curtain on the economics of the Dark Age, and lighting the way to unprecedented economic growth and change.